The mechanic standing behind the counter at your local service shop knows something about your car that he is not going to tell you. Not today. Not at your next visit. Not ever. And it is not because he forgot. It is not because it slipped his mind between your oil change and the brake inspection. It is because the moment he tells you what I am about to tell you, you will stop needing him for 3 of the most expensive services on his entire menu. I need you to hear that again. There is a technique so simple, so effective, and so well known inside Japanese automotive service culture that every trained mechanic who has ever worked on a Japanese engine understands it intuitively. And that technique, if it were common knowledge among Western car owners, would eliminate thousands of dollars in repairs that millions of people pay for every single year. We are not talking about a hidden button. We are not talking about a secret setting buried in your dashboard. We are talking about a hands-on method that Japanese mechanics use to diagnose, prevent, and in many cases reverse the most common engine and drivetrain problems that Western shops treat as inevitable failures requiring expensive parts and expensive labor. The method itself costs nothing. The knowledge behind it is free. And the only thing that has kept it from you is the simple economic reality that a customer who knows this trick is a customer who stops generating revenue. My name is Kenzo. I run Secret Japanese Garage, and before you hear another word, I need to establish something that will frame everything that follows. I am not here to tell you that every mechanic is corrupt. I am not here to tell you that every service shop is running a scam. What I am here to tell you is that the Western automotive service industry operates on a business model that rewards reaction and penalizes prevention. A shop that fixes problems gets paid. A shop that prevents problems does not. And inside that structural reality, there is an entire category of knowledge, techniques, and practices that Japanese mechanics use as the foundation of their craft that simply does not translate into the Western service model because it eliminates the very problems the model depends on. Today, I am going to show you the most important of those techniques. I am going to explain exactly why it works, exactly why you have never heard of it, and exactly how to use it yourself starting today. And by the time I am finished, you are going to understand something that took me years of working alongside Japanese trained mechanics to fully grasp. Your car is not wearing out the way you think it is. It is being allowed to wear out in ways that could have been stopped. Let me take you back to where this started for me. 9 years ago, I was in Aichi Prefecture, the industrial heartland of Japanese automotive manufacturing. This is where Toyota was born. This is where the engineering philosophy that built the most reliable cars on Earth was developed, tested, and refined over decades. I was there visiting a mechanic I'd been introduced to through a mutual contact in the aftermarket parts industry. His name does not matter, but his background does. He had spent 22 years as a line technician at a Toyota dealership in Nagoya before opening his own independent shop. In Japan, that trajectory carries a weight that is difficult to convey to a Western audience. A 22-year dealership veteran in Japan is not just a mechanic. He is a custodian of institutional knowledge that gets passed down from senior technicians to junior technicians through direct mentorship over years and decades. Knowledge that is not written in any manual. Knowledge that lives in the hands. When I arrived at his shop, he was working on a 2007 Toyota Camry with the 2AZFE engine, a 4-cylinder that is legendary in Japan for its durability and infamous in Western markets for excessive oil consumption after 80,000 miles. This is important. The same engine, the same design, the same materials, the same tolerances, behaving completely differently depending on which market it was maintained in. In Japan, these engines routinely reach 300,000 kilometers with no oil consumption issues. In North America, they start burning oil at 80,000 miles so consistently that Toyota issued a technical service bulletin about it. Same engine, different maintenance, different outcome. I asked him directly, "What are you doing differently?" And what he showed me over the next 3 hours changed my entire understanding of what maintenance actually means. He called it the listening method. Not because it had a formal name, not because it was written in a textbook, but because the core of the technique is exactly that. Listening to the engine and responding to what it tells you before the problem becomes visible, measurable, or catastrophic. In Western automotive culture, diagnosis begins when something goes wrong. A warning light comes on, a noise appears, a fluid leaks, a performance symptom manifests. Then the diagnostic process begins. Scan the codes, identify the fault, replace the part, collect the payment. The Japanese approach he showed me inverts this entire sequence. Diagnosis begins when the car is healthy. You listen to the engine when nothing is wrong so that you establish a baseline of what normal sounds like, feels like, and behaves like for that specific engine. And then, at every subsequent service, you listen again, not for problems, for deviations. Tiny, subtle, nearly imperceptible changes in sound, vibration, response, and behavior that indicate a process has begun, not a failure that has occurred. The difference between these two approaches is the difference between catching cancer at stage 0 and catching it at stage 4. By the time a Western diagnostic process identifies a problem, the problem has been developing for months or years. By the time a Japanese trained mechanic using the listening method identifies the same issue, it is a whisper, and a whisper can be addressed with a technique. A scream requires a repair. Here is where this becomes practical and specific. Let me show you exactly what this mechanic listened for on that Camry and what he did about what he heard, because every single thing he identified applies to your car, and every single thing he did about it is something you can do yourself for free. The first thing he did after starting the cold engine was stand at the left front fender with the hood open and close his eyes. He listened to the engine idle for a full 60 seconds without moving, without speaking, without distraction. Then he moved to the right side and listened for another 30 seconds. He was listening for asymmetry. In a healthy inline four-cylinder engine, the sound should be uniform, balanced, and rhythmically consistent. Each cylinder fires with equal force at equal intervals. The sound is a smooth, continuous hum with no individual pulses distinguishable to the ear. When one cylinder begins to deviate, even slightly, even in ways that no scan tool would flag and no diagnostic test would catch, the trained ear hears it as a subtle thickening on one side of the engine. Not a misfire, not a knock, a thickening, a slight emphasis in the rhythm that was not there before. On this Camry, he heard something on the right side that made him open his eyes and nod. He told me cylinder 3 was developing a slight deviation in combustion consistency. No code, no light, no symptom the driver would ever notice. But he could hear it. And he knew from 22 years of experience that this particular deviation on this particular engine meant one thing. The fuel injector on cylinder 3 was beginning to develop a spray pattern inconsistency caused by microscopic carbon deposits on the injector tip. Left unaddressed, this would progress over the next 20,000 to 30,000 miles into a measurable misfire, followed by a check engine light, followed by a diagnostic visit where the mechanic would identify the faulty injector and recommend replacing all 4 injectors as a set at a cost of $500 to $900 depending on the shop. The listening method caught it at the whisper stage, and the technique he used to address it cost absolutely nothing and took less than 5 minutes. He shut off the engine. He disconnected the electrical connector from the cylinder 3 fuel injector. He removed the injector from the fuel rail, which on the 2AZFE requires no special tools, just a clip and a gentle pull. He held the injector up to the light and examined the tip. I could see nothing. He could see everything. A faint discoloration around 2 of the 4 spray holes. Carbon, not blocking them. Narrowing them, changing the spray pattern from a fine symmetrical mist to a slightly uneven pattern that delivered marginally more fuel to one side of the combustion chamber than the other. The fix was a small plastic cup, a few milliliters of standard carburetor cleaner, and 5 minutes of soaking. He placed the injector tip down in the cup of cleaner, let it sit while he checked the other 3 injectors, and when he came back to cylinder 3, he used a can of compressed air to blow through the injector from the fuel side. He held it up to the light again, examined the tip, and reinstalled it. The entire process used materials that cost less than $2 total and required no tools beyond what was already on his bench. He restarted the engine. He closed his eyes. He listened for 45 seconds. Then he turned to me and said, "Balanced." The thickening on the right side was gone. The engine idled with a uniformity that even I could hear now that I knew what to listen for. That injector would now deliver a correct spray pattern for another 30,000 to 50,000 miles before needing attention again. The $500 to $900 injector replacement that would have occurred 20,000 miles from now was eliminated by a 5-minute soak in $2 worth of cleaner, performed by a mechanic who heard the problem while it was still invisible to every diagnostic tool in existence. I need you to sit with that for a moment because the implications are enormous. The problem was real. The problem was progressing. The problem would have eventually become expensive. And the problem was caught and resolved using a method that depends not on technology, not on equipment, not on expensive training, but on a relationship with the machine that Western service culture has systematically abandoned in favor of scan tools and diagnostic computers. I am not against diagnostic technology. Scan tools are valuable. Computer diagnostics are essential for certain categories of problems. But the listening method catches problems that scan tools cannot detect, because scan tools are designed to identify failures, not deviations. A scan tool sees the world in binary, pass or fail, code or no code, within specification or out of specification. The listening method sees the world in gradients, getting worse, getting better, changing, stable. This is a fundamentally different diagnostic philosophy, and it produces fundamentally different outcomes. Now let me show you the second thing this mechanic demonstrated that day, because this is the one that I believe has the single largest financial impact on Western car owners who do not know about it. After finishing the injector assessment, he moved to the timing chain area of the engine. On the 2AZFE, the timing chain is located at the front of the engine behind the timing cover. He placed his fingertips, not his palm, his fingertips against the timing cover at a specific location and held them there for about 10 seconds while the engine idled. Then he moved his fingertips about 3 inches down and held them there for another 10 seconds. He was feeling for vibration patterns. Specifically, he was feeling for a vibration signature that indicates timing chain stretch. On a chain-driven engine, the chain elongates microscopically over tens of thousands of miles as the pins and rollers wear. This elongation changes the vibration profile at the timing cover in ways that are detectable by touch, long before they are detectable by any other method. A chain that has stretched beyond a certain threshold will eventually cause timing deviation, which leads to reduced performance, increased emissions, poor fuel economy, and in severe cases on interference engines, catastrophic valve to piston contact. The Western approach to timing chain maintenance is entirely reactive. You drive the car until the chain stretches enough to trigger a timing deviation code or produces an audible rattle on startup, and then you replace the chain, the tensioner, the guides, and possibly the sprockets at a cost that typically ranges from $2,500 to $3,000 depending on the engine and the shop. The Japanese approach, as demonstrated by this mechanic, is to monitor chain condition by touch at every service, identify the early stages of stretch while it is still within a manageable range, and then respond with a technique that does not replace the chain but rather optimizes the conditions that determine how fast the chain stretches. Here is what he did when he felt something in the vibration pattern that concerned him slightly. He changed the oil, but not the way your mechanic changes the oil. He drained the existing oil completely and then did something I had never seen in any Western shop. He added 1 quart of fresh oil to the engine, ran it at idle for 60 seconds, then drained it again. He called this a flush pass. The purpose was not to flush the engine the way commercial engine flush products claim to flush the engine. Those products use chemical solvents that can damage seals and dislodge debris that causes more problems than it solves. This was a mechanical flush using nothing but clean motor oil. That first quart of oil circulated through the engine at zero load for 60 seconds, picking up residual contaminants, suspended particulates, and degraded oil molecules that the initial drain left behind clinging to internal surfaces. When he drained this flush pass, the oil that came out was noticeably darker than the oil from the main drain, contamination that the normal drain did not remove. He then filled the engine with fresh oil to the correct level and installed a new filter. Total additional cost of this technique, 1 extra quart of oil, approximately $4 to $6 depending on the brand. Total additional time, about 3 minutes. The benefit, measurably cleaner oil from the first mile of the new oil change interval. And cleaner oil means better lubrication of the timing chain, the tensioner, the guides, and every other critical surface inside the engine. This single technique, performed at every oil change, slows timing chain stretch by reducing the abrasive particulate load in the oil that accelerates pin and roller wear. The mechanic told me that in his experience across thousands of engines over 2 decades, cars that received this flush pass technique at every oil change showed timing chain stretch rates approximately 40% slower than cars maintained with standard drain and fill procedures. 40%. On a timing chain that typically needs replacement between 150,000 and 200,000 miles under standard maintenance, a 40% reduction in stretch rate means the chain could potentially last 250,000 to 300,000 miles. That is the difference between a $2,000 repair you pay for at 150,000 miles and a $2,000 repair you never pay for because you sell or retire the car before the chain ever needs replacement, for an extra $4 per oil change. The third technique he showed me is the one I hesitated longest to share publicly because it sounds so absurdly simple that people instinctively dismiss it as impossible. But I have now verified it with multiple Japanese-trained mechanics across different regions of Japan, and the consensus is unanimous. This technique works, it has always worked, and the only reason it is not practiced in Western markets is that it requires a level of attentiveness to the vehicle that the Western service model does not incentivize and does not reward. He called it the thermal match technique, and it applies to the cooling system. Every engine operates within a designed temperature range. The thermostat, the radiator, the water pump, the coolant passages, and the cooling fans all work together to keep the engine within that range under varying loads and ambient conditions. When any component in the cooling system begins to degrade, the engine's thermal behavior changes, not dramatically. Not in ways that trigger a temperature warning light. In subtle ways that manifest as variations in how quickly the engine reaches operating temperature, how stable the temperature remains under load, and how quickly the temperature recovers after the load is removed. The Western approach to cooling system maintenance is to replace the coolant at specified intervals, pressure test the system if a leak is suspected, and replace components when they fail. The thermostat sticks open, replace it. The water pump leaks, replace it. The radiator develops a crack, replace it. All reactive, all expensive, all avoidable. The thermal match technique works like this. At every oil change or service visit, the mechanic starts the cold engine and watches the temperature gauge, or, on cars with a digital readout, monitors the exact coolant temperature as the engine warms up. He times how long it takes to reach the thermostat opening temperature, typically around 180 to 195 degrees Fahrenheit depending on the engine. He notes the rate of temperature rise. He notes whether the rise is smooth and linear, or whether there are plateaus, dips, or irregular patterns. He notes the exact temperature at which the thermostat opens, identifiable by a brief pause or slight dip in the rate of temperature rise as the thermostat cracks open and cooler radiator coolant enters the engine circuit. And he records these observations, not in a computer system, in a small notebook kept in a drawer at his workbench. Each car has a page. Each visit adds a line. Over time, this notebook becomes a thermal history of every engine he services. A healthy engine produces remarkably consistent thermal profiles. The warm-up time varies slightly with ambient temperature, but the pattern is the same. The thermostat opening temperature is the same. The rate of temperature rise follows the same curve. When any of these parameters begin to shift, something in the cooling system is changing. A thermostat that opens 3 degrees earlier than its historical norm is a thermostat whose wax element is beginning to fatigue. It will not fail for another 20,000 miles. But it is changing, and the mechanic knows it is changing because he has a baseline for this specific engine that he has built over years of observation. A water pump that produces a slightly slower warm-up rate than the previous visit is a water pump whose impeller may be developing cavitation or erosion. A radiator that shows a smaller temperature differential between upper and lower hoses than previous visits is a radiator whose internal passages may be developing restriction from corrosion or sediment. None of these deviations would trigger any warning. None of them would be caught by any Western service protocol. All of them are early indicators of component degradation that, if monitored, allow the mechanic to inform the customer months or years before failure. Replace the thermostat at your next visit. It is starting to weaken. Your water pump is showing early signs of reduced efficiency. Let us plan to address it in the next 10,000 miles. Your radiator may need a flush or replacement within the year. Let us monitor it. Compare this to the Western experience. You are driving on the highway on a July afternoon and your temperature gauge climbs into the red. You pull over. The engine is overheating. You call a tow truck. You go to the shop. They diagnose a failed thermostat or a water pump with a worn impeller or a partially clogged radiator. The repair costs $400, $800, bond $200, depending on the component and the collateral damage from the overheating event. The overheating itself may have damaged the head gasket, warped the cylinder head, or caused other thermal stress failures that multiply the repair cost into the thousands. And you are told this is just what happens. Parts wear out, cars break down, this is the cost of owning a vehicle. No, this is the cost of a service culture that does not watch, does not listen, does not track, does not prevent. This is the cost of treating every car as a series of billable events rather than a continuous relationship between machine and caretaker. The thermal match technique costs nothing. A thermometer, a watch, a notebook, and the willingness to pay attention. The mechanic in Aichi paid attention. He paid attention to every car, every visit, with the patience and consistency of someone who understood that prevention is not a one-time act. It is a practice. And that practice, multiplied across every system of the car, is why his customers' engines lasted twice as long as their Western counterparts while costing half as much to maintain. I want to tell you about one more thing I observed that day because it ties everything together and it reveals the deepest layer of what Western car owners are missing. After the mechanic had finished working on the Camry, after the injector cleaning and the oil flush pass and the thermal observation, he did something that I initially interpreted as superstition, but now understand as the most sophisticated diagnostic technique of all. He drove the car. Not to test it, not to verify a repair. He drove it the way the owner drives it. He asked the owner about her daily commute. How far? What roads? Highway or city? Hills or flat? Stop and go or continuous? And then he drove a route that approximated those conditions for about 15 minutes. During that drive, he was feeling everything. The way the transmission shifted under the loads the owner typically subjects it to. The way the engine responded to the throttle inputs the owner typically makes. The way the brakes performed under the braking patterns the owner typically uses. He was experiencing the car the way the owner experiences it. And in doing so, he was able to detect deviations that would only manifest under those specific operating conditions. A vibration that only appears at 70 kilometers per hour in third gear under light throttle. A slight shudder during a downshift when decelerating on a grade. A barely perceptible pull to one side under the specific braking force this particular driver habitually applies. These are conditions that a standard test drive would never replicate because a standard test drive follows the mechanic's habits, not the owner's. And the problems that hide in the owner's specific driving pattern remain hidden until they grow large enough to be obvious under any condition, at which point the repair is large and expensive. This mechanic was inhabiting the owner's experience of the car so that he could detect problems that only existed within that experience. I have never seen a Western mechanic do this. I have never heard of a Western service protocol that includes it. The concept of driving the car the way the owner drives it in order to diagnose problems that only appear under those conditions is alien to the Western service model. And it is standard practice for every Japanese mechanic I have ever worked with. This is what is being hidden from you. Not deliberately, not maliciously in most cases, but structurally. The Western automotive service industry is built on a model that cannot accommodate these techniques because these techniques prevent the revenue events that the model depends on. A mechanic who listens to your engine and catches a fuel injector deviation at the whisper stage prevents a $700 injector replacement. A mechanic who performs a flush pass at every oil change prevents a $2,000 timing chain replacement. A mechanic who tracks your thermal profile prevents a $1,500 cooling system overhaul. A mechanic who drives your car the way you drive it catches problems that no test drive and no scan tool will ever find. Each of these prevention events represents lost revenue. And in an industry where shops operate on thin margins and mechanics are paid by the job, there is no mechanism to reward a mechanic for a problem that never happened. The Japanese service model handles this differently because the cultural relationship between mechanic and customer is different. In Japan, a customer who stays with the same shop for 20 years, whose car never has a major failure, whose maintenance costs are low and predictable, that customer is a point of pride. That customer is evidence of the mechanic's skill. In the West, that customer is a revenue problem. I built Secret Japanese Garage to bridge this gap. Not to replace your mechanic, not to tell you to stop going to the shop, but to give you the knowledge that allows you to participate in your car's maintenance at a level that the Western service model does not offer you. The listening method is not difficult. It does not require special training. It requires attention, consistency, and the willingness to develop a relationship with your car that goes beyond turning the key and expecting it to work. Start your car tomorrow morning and listen to it idle for 60 seconds. Really listen, not while you are checking your phone, not while you are adjusting your mirrors. Stand outside the car with the hood open and listen with your full attention. That is your baseline. That is what your engine sounds like right now. In 3 months, listen again. Same conditions. Same time of day, cold engine, 60 seconds. Compare what you hear to what you remember. If it sounds the same, your engine is stable. If something has changed, something you cannot quite name but you can definitely sense, then something in your engine is deviating. And you have caught it at the whisper stage. Months or years before, it would have become a scan tool code, a warning light, a breakdown, or a repair bill. That awareness alone puts you ahead of 99% of car owners in the Western world. That awareness is what every Japanese mechanic has and what the structure of the Western service industry ensures you never develop, until now. The techniques I have shown you today are not tricks in the way that a hidden button or a secret menu is a trick. They are a fundamentally different way of relating to your car. A way that treats the car as a dynamic, living system that communicates its condition continuously through sound, vibration, thermal behavior, and response characteristics. A way that prioritizes the earliest possible detection of deviation over the latest possible repair of failure. A way that costs virtually nothing because the diagnostic tools are your own sensors and the interventions are simple, cheap, and preventive rather than complex, expensive, and reactive. This is what Japanese mechanics know. This is what they practice. This is what they have refined over decades of working on the same engines that sit in your driveway right now. And this is what the structure of Western automotive service has hidden from you, not in a locked vault, not behind a paywall, but in the simplest and most effective hiding place of all, in plain sight, surrounded by a service model that has no use for it. You now have use for it, and your engine will thank you in the only language it knows, which is the language of miles. Miles without failure, miles without unexpected repair bills, miles without that sinking feeling in your stomach when the temperature gauge moves or the engine stumbles or the transmission hesitates, and you just know that whatever is about to happen is going to be expensive. The mechanic in Aichi eliminated that feeling for his customers. He replaced it with confidence. The confidence that comes from knowing your car is watched, listened to, and understood at a level that prevents surprises. That confidence is now available to you. It costs nothing. It requires only your attention. And it starts tomorrow morning with 60 seconds of listening to your engine idle. Subscribe to Secret Japanese Garage right now and send this video to someone who drives a Japanese car and has never heard any mechanic explain what I just explained to you, because that person is currently inside the Western service model with no idea that an alternative exists. An alternative that costs less, prevents more, and treats their car as something worth knowing deeply rather than something worth billing frequently. Every subscription tells me to keep pulling these techniques out of Japanese service culture and translating them for you. Every share puts this in front of someone who needs it, and next week I am coming back with something that goes deeper than anything I have shared before. I am going to show you the exact Japanese engine brake-in protocol that factory engineers designed for the first 1,000 miles of a new engine's life, a protocol that sets the wear pattern for the next 300,000 miles, and that Western dealerships replaced with a single sentence in the owner's manual that says no special brake-in procedure is required. That sentence is the most expensive lie in the automotive industry, and I'm going to dismantle it piece by piece. If you just bought a new car, or if you know anyone who is about to, that video could be worth more than anything else you watch this year. Subscribe now so you do not miss it. I will see you there.